and you're going to also focus on the bottom of the screen. And what you're going to see is as I bring this closer, it's going to say door closed. As I bring this open or further away, door open, door closed, door open, door closed. Hey guys, what's going on today? So today I want to talk to you about something completely different. One of the things you'll notice right up the bat is we have a completely different IDE up here, and that's because we're going to delve into a different world of Python today, and that's called MicroPython. So MicroPython is a great framework to use when we're actually working with something like a microcontroller. So as you can see here, this is an example of a microcontroller. This is called an ESP8266 Node MCU board. And they're relatively cheap. They probably cost about 10 bucks a board or so, but what you can do with it is absolutely amazing, especially when you roll in something like MicroPython on top of it. So in the past, I've really used the Arduino language, but I basically used that in the past to create a lot of different microcontrollers. Now in today's session, what we're going to do is we're actually going to create something that's going to allow us to take something like a read switch, which is right here. And I'm going to take this read switch, connect it to the microcontroller, and then I'm going to have simulate as if somebody's opening or closing a door. And what it's going to do is on the bottom of the screen in the IDE around this area here, what you're going to see is it's going to say whether it's open or closed. So let me go ahead and activate this. We're going to go to serial, so it's connected to this serial port here, and basically this is just connected using a regular USB cable to a micro USB that goes into this, and this goes into my computer. And so once we have that open, so we have two files in here. One is called boot.py and one is called main.py. Boot.py is basically used to execute any kind of command you have in here. So say you wanted to connect this to some kind of a Wi-Fi router. Upon boot, it'll do that, and then it'll eventually go into main.py, which is where we're going to focus today. And so the other thing to keep in mind with boot.py as well is this is a file, like I said, that's also going to go ahead and load your SSID. So right now we're kind of working in a dev environment, but if you wanted to put this in production, and that is actually hang this off of a door if you wanted, you just got to give it some power and attach the wires. But then you also need to make sure that this actually connects to your home automation system somehow. So the other thing you'd also put in boot.py is you'd also put in something like an MQTT protocol. And so that's basically stands for mosquito protocol. And what that does is that will send signals to your home automation system through an MQTT protocol. And it'll tell your home automation system, hey, listen, I just opened or I just closed. And we will cover that off later on. I think right now I wanted to really just focus on the main.py. I'm going to have another tutorial coming on how do you actually use this with boot.py. Put in all the stuff like your SSID, put in the MQTT server, and we'll actually test it out on a door as well to see how it works. But really, today's focus is really on getting this working in a dev environment so that once we have it how we want it, we can productionize it. Now, I actually got this code and modified it slightly from an Adafruit website, which I will put in the description for you guys to take a look at. It's a great tutorial. But essentially what this is going to do now, so if I were to go ahead and just hit download and run, what you're going to see down here is you're going to start seeing things like open or close. So what I'm going to do is I'm going to take my microcontroller here, and you're going to also focus on the bottom of the screen. And what you're going to see is as I bring this closer, it's going to say door closed. As I bring this open or further away, door open, door closed, door open, door closed. And so the whole point of this is how do you use something like this as a simple microcontroller? Like I said, 10 bucks. You can probably connect, I think, 4 or 5 of these just to one microcontroller. So if you think about setting up a whole new home alarm system, it actually can become very cheap if you start using a microcontroller. Now, reliability sometimes is questionable with these ESP boards. There's also something called Pi boards that are specifically for MicroPython that you may want to consider alternatively. But we're going to go ahead and I'm going to show you how this works, and we're going to go ahead and program this. And I'm going to walk you through line by line what all of this means. Now, the first thing to know is there's actually a pinout for your ESP Node MCU. And so the pinout's basically going to show you what pin number is configured to what letter, whether it's going to be D1, D2, and how that's configured to the actual GPIO pin. So if I were to bring this in here, this is basically the board we're looking at. What we're going to do is we're going to use pin number 12, which is also considered D6. So if you actually look at this, I'm going to try my best to focus. I'm not sure if I can get it perfect. But if you were to look at this, basically this lead here is connected into D6, and this lead here is connected into ground. And that's all you need, because the code is going to do the rest of the magic for us. So if I were to take this back, and if I were to just walk through the code with you here. So I should also say MicroPython is actually a modified version of Python. So it's a very lightweight version. I wouldn't say that it has everything and all the capabilities of regular Python. The other thing to keep in mind is these microcontrollers have like a megabyte of flash memory. So there's not a lot of memory in this, so it's really meant to do lightweight tasks. But basically, Machine is a Python library that helps to map to your different GPIO pins on your actual microcontroller. And then we already know what the time module. So here all I'm doing is I'm setting my pin, and I've said pin 12, which like I said is equal to D6, which is where we've gone ahead and added that lead in. And I said we're going to make this pin, and we're going to make this pin an input pin. So I want to know when things are changing with this pin, because as I'm moving my magnet closer and closer, I'm sending an input to it to say, are you going to be on or are you going to be off? And I'll kind of explain what that means in a second. The next thing we're going to do is we're going to write a quick while statement. And in this while statement, all we're saying is that let's go ahead and get the original value for this. If the original value is something like door closed, let's go and read that state 0.01 seconds later. And if it's still the same state, then just leave the same print statement. But if the state has changed, then we're going to change the print statement to door open. Now here's what I mean by that. What the code is doing is it's saying, okay, I'm going to go ahead and read this, and it's going to say I'm on. And the problem with this while statement is if I don't do this kind of a loop, it's going to continue printing door closed. It's going to just say door closed all the way down here over and over again. By doing this, what I'm saying is if I've actually gone ahead and done something with the pin, and that is I've closed the state, now it's going to say, wait a minute, this is not equal to this. So let me just make sure that I leave door closed only. But the minute that state changes and this changes to something new, then it's going to go to door open. Now the way this stuff works is rw.value is going to return either a 1 or a 0. And what it's going to say is, so it's going to say am I 1 and then have I changed to 0. And if I've changed to 0, that means my state has changed. But if my state hasn't changed, then don't reprint this again, because I'm just going to be looping over and over again. And so another way you can look at values for your microcontroller is you can do something like rw.low, which basically means 0, or you can do rw.high, which basically means 1. So this is just an introduction into microcontrollers. There's a lot more cool stuff you can do with this. But if you were to go ahead and just copy the way this is set up, I'll put a link to the description of the actual items that I've used in this on Amazon. You can pick them up fairly cheap, or you can go on eBay and it's even cheaper. You just got to wait a little bit longer. I'll also go ahead and put this diagram, a link to this diagram, so if you do choose to buy this chip, then at least we have the same chip and you can follow this instruction. And I'll leave the boot.py and main.py on GitHub as well, so you can go ahead and download it, but I'll also leave the link to where I got this code on Adafruit's website, and you can go ahead and read that as well. But honestly, it's that simple to get started with microcontrollers. I'm also going to leave a link to PyCraft, MicroPycraft, which is the IDE that I use for this. And the reason why I use this IDE is just because I can go ahead and connect through serial port to my 8266. So hopefully you guys enjoyed this tutorial. If so, hit that like button, hit that subscribe button, and I'll talk to you later. Bye-bye.